Okay, so we're going to be going over solving trig functions, solving trig equations. And so I'm going to start with just one, which is just going to be the sine of theta is equal to 1/2. Okay, what you have to remember, and we've done this with terminal and coterminal, is, well, what is this asking? This is asking when is sine 1/2. So we go back to our good old unit circle, and we go all the way around. And where is sine? Well, sine is positive, so sine is 1/2 here and 1/2 here. And if you guys remember, sine is going to be at 1/2 is going to be pi over 6, and it is going to be 5 pi over 6. So we have two solutions there. I know that pi over 6 is a solution, 5 pi over 6. But that's not the only thing that I can replace theta with that will give me 1/2. What you have to think about is actually any coterminal angle with pi over 6 would also give you 1/2. So that guy, pi over 6, so you have your pi over 6 plus 2 pi, which is 12 pi over 6, is going to give you 13 pi over 6. So that would also be, so I know 13 pi over 6 would be another solution. Also, anything coterminal with 5 pi over 6. So if we went all the way around, so we have our coterminal, so we have 5 pi over 6 plus 12 pi over 6, and that's going to be 17 pi over 6. And we could keep going infinitely. We can go actually forwards, we can go backwards, but there are an infinite number of solutions for this, okay? And there is a way to write this. I also want to look at this briefly, looking at a sine graph. So we have our sine graph here, goes up, goes down, goes back up, goes down. We don't want to mess with the dinosaurs there. So here, this is pi, this is 2 pi, this is going to be, so we have our pi over 2, our 3 pi over 2, 5 pi over 2, this is going to be 3 pi, etc. Remember that this is 1 and this is -1. At 1/2, you can actually look at the graph and figure out how many solutions as well. In this case, if I just draw a line here, you'll see that we have all of the solutions that we have up here are also here. This 1/2, when y is equal to 1/2, well, that's going to be your pi over 6. This guy right here is going to be your 5 pi over 6, and then this guy right here is your 13 pi over 6, and this guy right here is your 17 pi over 6. So we can see that lengthen out and represented along our graphs as well. Now, how do we write that? I mean, that's the bigger question. How are we going to write all of our what theta is equal to? This is actually pretty easy. So we look at our base angles, we look at our pi over 6 and 5 pi over 6, the ones in the unit circle, and I know it's going to be that angle and any coterminal angle. And how I find my coterminal angles is I add 2 pi. But I can add 2 pi n number of times. So I could add 2 pi times 0, so I would just not be adding anything. I could add 2 pi times 1. Well, 2 pi times 1 is going to be our, or not 2 pi, sorry. Pi over 6 plus 2 pi times 1 is going to give me 13 pi. Okay, adding 2 pi. It could be 2 pi times 2. I could have a -1 in there, and that would actually tell me that my coterminal angles the other way. Grab a different color. So I could also have coterminal angles going in the opposite direction. So our two solutions to this are going to be theta is equal to pi over 6 plus any coterminal angle of pi over 6. It will also be 5 pi over 6 and any coterminal angle with 5 pi over 6. And that's all you have to do. That's how you would write your answers with that. Okay, so what we're going to do, I'm just going to do probably about 5 examples of some different things. And we'll see how that goes. Actually, I won't, because you can't respond to me. So if I ask you to solve in this case, and we have 3 times the sine of x minus 2 is equal to 5 times the sine of x minus 1. Okay. We did this logs a little bit with the same bases. But basically, when you see an equation like this is not that complicated. This is actually basically an algebra 1 problem, because sine of x doesn't have to be here. Those are just like terms. So we actually can treat this as like 3x minus 2 is equal to 5x minus 1. Now you are more than welcome to like solve this and replace the x when you get your solution with sine. I'm going to keep sine here because I think it's good for you. So what I'm going to do is I'm going to subtract 3 of something, and I subtract 3 of something here, which I would normally do if I was solving, and this ends up being 2. Well, if I have 5 of something minus 3 of something, it's going to be 2 of something. In this case, it's sine x minus 1. I add 1, I end up with negative 1 is equal to 2 times the sine of x. I want to get sine, cosine, tangent, whatever my ratio is by itself. So I divide by 2, and the sine of x is equal to negative 1/2. So now we're back to basically where we were with the last problem. So all I have to do here is I say, well, where is sine negative 1/2? Well, it's going to be here and here. And so I know that this is going to be, this distance here is pi over 6, and this distance here is pi over 6, because I remember my unit circle. I don't have any domain restrictions. It just says, what could it be? And so I know that x is going to be, in this case, it's going to be 7 pi over 6 plus 2 pi n. So it's going to be any, it's going to be this angle plus any coterminal angle. And then my other solution is going to be 11 pi over 6, or negative pi over 6, because it'll generate the same graph. 11 pi over 6 plus 2 pi n, and that will be your solution. So those aren't too bad at all. Okay. So let's get to some more interesting ones. You know, we all have different opinions of interesting. So for my next example, you're going to solve for theta on the interval from 0 to 2 pi. We don't include both 0 and 2 pi because they take you back to the same spot, so you'd end up repeating solutions. It's not going to come into play here. So I have negative tangent squared x is equal to negative 3. Okay. The one notation thing that you do need to know is that tangent squared x, negative tangent squared x, is the exact same thing as the negative of tangent squared x. So this and this are the same thing. I'm going to leave this because you don't see it this way. You always see it this way, but they actually mean exactly the same thing. So first thing I'm going to do is I'm going to divide by negative 1, because if I was solving for x, that's what I would do. So I end up with a tangent squared of x is positive 3. I answer the question, if something squared is 3, then that something, and this is where you have to be careful, could be positive or negative radical 3. So we do have our two solutions here. Now, if I think about it, now this is where we want it to be. So I think about it, I do my little thing here, and I say, okay, well, where is tangent positive? So tangent would be positive here and positive here. Where is tangent radical 3? That's going to be pi over 3 here. It's pi over 3 here. But I also know that tangent is negative radical 3. So it's going to be pi over 3 here and pi over 3 here. So in this case, you're going to have a total of 4 solutions, which is possible. You can end up with a lot of solutions. We are only looking at these ones here. We're not going to do the pi times n, because this indicates here that all I'm looking at is my unit circle. So my solutions, x is going to be equal to, I have my pi over 3. My next one, remember that this is 3 pi over 3, is going to be 2 pi over 3. I know that that would make that 4 pi over 3. And I remember that this is 6 pi over 3, so my last one would be 5 pi over 3. And that is it for your solutions. It's going to be an easier one, but I only want to do 2 more examples, just not to make this video too long. So same instructions for the next 2 examples. So our next one, I keep saying, stop saying so. Our next one is going to be a bit different, and I'm going to have to look at this to write it down. So I have -4 cosine theta minus cosine squared theta is equal to 3 cosine squared theta plus 1. I know this looks awful, but if you know how to solve a quadratic, you'll be fine. Okay, similar to what I said at the beginning with these quadratic looking ones, I would actually kind of replace all of my cosines with x to make it more recognizable. So instead of looking at it this way, I'm going to say this is going to be -4, but instead of cosine, I'm going to put x minus, this is going to be x squared is equal to 3x squared plus 1. What I want you to do, so I just replaced all of my cosines with x, is just pretend that you're solving that. And once you get it into its factored form, I want you to replace your x with cosine. So for this, I don't like my lead coefficient negative, so I'm going to add x squared. I'm also going to add 4x to each side. So I end up with 0 is equal to 4x squared plus 4x plus 1. I'm going to have to do some factoring. This is one where I'll have to split the middle. So this is going to be 4x squared something something plus 1. I have to figure out what the something something is here. So I'm looking for two numbers. They have to multiply to be 4, and they have to add to be 4. And that is going to be 2x and 2x. 2x times x plus, or times, every single time, 2x times 2x plus 1 plus 1 times 2x plus 1. 0 is equal to 2x plus 1 times 2x plus 1, which is essentially 2x plus 1 squared. Okay, at this point here, right here, when I'm in my factored form, I rewrite it because x was not here. It was the cosine of theta. So this is going to be 2 times the cosine of theta plus 1 squared is equal to 0. I get rid of my squared by taking the square root. So this is 2 cosine theta plus 1 is equal to 0. Doesn't have to worry about positive and negative because 0 doesn't have a positive and negative. 2 cosine theta is equal to -1. The cosine of theta is equal to -1/2. And here we go. This is where we are. We just have to think about our unit circle stuff. Where is cosine negative? In the second and third quadrant. What angle has a cosine of -1/2? It's going to be pi over 3 and pi over 3. So what are my solutions? Theta is going to be equal to, this is going to be 2 pi over 3 and 5 pi over 3. And there we go. That is how we do the factoring ones, which aren't too bad. As long as you know how to factor and you guys are good at it. All right, very last problem I wanted to go through with you. You ready? You guys aren't there to complain, so I don't know. We'll just go with it. So you might get something weird, like -2 radical 3 cosecant theta times cosine theta plus 3 cosine theta is equal to -3 cosecant theta plus 3 cosine theta. And that looks pretty ugly. I agree with you. Okay, that's what you're thinking. This is not what I'm going to put an x in for because I have two variables. So what I do, all else fails, I'm like, okay, well, let me set it equal to 0 because a lot of the time we can do something setting it equal to 0. So I'm going to add 3 cosecant theta to each side. Now, this does not have any like terms, so I can't combine it with anything. And I subtract 3 cosine theta from each side. And then these two end up subtracting to be 0. So I end up with -2 radical 3 cosecant theta times cosine theta plus 3 cosecant theta is equal to 0. Now, we still have an issue because we have two different trig ratios, but Like I said, a lot of the time it does come down to factoring. In this case, it just comes down to a greatest common factor. I see that they both have cosecant, so I'm going to divide out a cosecant, so I end up with -2 radical 3 cosine theta plus 3 is equal to 0. Now it is in completely factored form, and I've separated my two trig ratios. So the first thing is cosecant theta being equal to 0. So I know we didn't graph cosecant just for time, but I want you to think about what sine is. Well, sine in the unit circle is your y value over 1. So your cosecant is going to be 1 over your y value. Can this ever be 0? Okay, when y is 0, it's undefined. So cosecant actually can never be 0. Sine can be 0 when your y value is equal to 0, but cosecant, since your radius is all the same, so just something, if that's too much to think about, cosecant can't be equal to 0. Neither can secant. So secant and cosecant can't be equal to 0. When we did that table, when we were doing our trig identities, we ended up going over that. All right, so let's go see if we have a solution here. So -2 radical 3 cosine theta plus 3 is equal to 0. We have, I subtract 3, -2 radical 3 cosine theta is equal to -3. I have cosine of theta is equal to, now I know a negative divided by negative is a positive, so it ends up being 3 over 2 radical 3. But maybe you don't recognize that because I said we don't always have to rationalize. So what you can do is you can rationalize this. So this ends up being radical 3 over radical 3. So this is 3 radical 3 over 2 times 3 is 6. And when I simplify, it should be something much more recognizable. It is radical 3 over 2. So where is cosine positive radical 3 over 2? Well, we have the first quadrant and third quadrant. And where is it radical 3 over 2? At pi over 6. And it's going to be 11 pi over 6. And so those are our answers. It's pi over 6 and 11 pi over 6. You could also write negative pi over 6 as well. Actually, you can't write negative pi over 6, excuse me, because your domain is from 0 to 2 pi. So you can't write this as a negative pi over 6 because it's not in your domain. So don't do that, just do this. I hope this was helpful, and that's about it.